All right, so let's open up the raster data manipulation notebook. So in this notebook, we will learn how to do most common image processing operations like format conversion, like cropping an image, like resampling, regridding an image, and multi-looking. The reason we are going through these exercises is you will quickly realize that writing custom tools for this, you are no longer going to be able to maintain it for every flavor of the operation that you want. So we, at least I have personally resorted to using GDAL for everything for these types of operations. And the other useful thing is it not only relevant for radar data, it spans any kind of satellite data, optical, or weather model, and so on. So GDAL is a nice tool that lets you work with all these different types of data sets with a common interface. So run the first cell. You should see, get the functionality in. Since I'm starting fresh on this notebook, let me download the stuff. It should be really quick. I'm gonna skip the StripMap part, but when we get to the cells, I will ask students to run it. If you have the StripMap folder, just make sure you point to the correct folder here. If you run the processing somewhere else. So go ahead, for students who have done StripMap app, you should have this, create that link. Okay, so the main utility for format conversion, for regridding, resizing, cropping is if you were doing this on a command line, it's called GDAL translate. I've included the link to its documentation. It provides you a whole bunch of options. We're going to walk through some of the most commonly, okay, like I said, you need to track down where you did your StripMap processing and use that for the link. For the StripMap app. Okay, so the very first common operation that we all encounter when someone gives you an image, this really is a problem from the old age where people hard-coded file formats in their code. That would not fly in any of the modern systems. No one does that anymore. So the first thing is somebody gave you a TIFF file, they want it in GMT file format because their code, they hard-coded the formats. The GDAL translates, for example, we will convert a file that is in GMT GRE format to a TIFF file. And the way we do it is called the GDAL translate command. And we can actually quickly load the data from the GRD file as well as the TIFF file and plot the difference to make sure that there's actually no information lost in conversion of file format. So this is a super useful thing, especially when you have to pass data in formats to other people who are not adept at handling the more specific formats, newer formats. Another useful thing when you can convert is you can, while you're converting formats, you can assign additional annotations in the process. Like we saw yesterday in POPs or in the StripMap app, sometimes you get these border images around, border region around the images where there's no data and we fill it with zeros. ICE has a very simple interface. It doesn't represent it clearly. So what we can do is here, I'm taking an ICE geocoded product. I can point to the VRT, and I'm converting it to a GeoTIFF file. But in the process of transformation, I can say assign a no data value to a 0. So GDAL will, anybody who's used to working with GeoTIFF will open the file and they see 0 is no data, and their tools will be able to work with it. So if you have done the linking correctly and you've run StripMap app, this cell should run. If anybody managed to run this 2 cells, I would ask you to quickly share your screen and show the output of what it looks like. Any volunteers?
Yeah, in my case, I thought I ran the whole thing all the way through. And this file, most of the files exist, but this file somehow doesn't exist. So maybe it crapped out. Yeah, so Enrique had the same issues, lots of people. I don't know if things changed in the default StripMap app or what, but maybe we should just change the file to another one.
Yeah,
up in the
we can easily change this to, is there another .core in the folder? Like phsig.core.go or something?
Let's take a look.
Yeah. Aha, so I see someone managed to run that.
Oh, okay, good.
So so then when you use GDAL info, like you did, oh, could you keep sharing your screen, Jessica? That was very useful.
Who was that? Jessica?
Yeah, so the first step, we translated it to a geotiff. And then the second step, we listed the details of the geotiff. So you clearly see the size of the image, the projection system. ICE produces everything in lat-lon. That's what it's representing. You'll also see, if you scroll down, a no data value. It says, oh, the data is of type float32 and has a clear label no data value. So if you import this into ArcGIS or QGIS, all those tools would readily identify the no data values in your imagery. Thanks so much, Jessica. So you had that file in that folder, or did you happen to change the file name in your case?
I removed the StripMap folder from the path, and then I ran, but then Paul noted that it's just a soft link, so I added it back, and it was also fine.
Awesome. Okay, so the file existed in the folder. So as long as it's pointing to the correct folder, it should work.
Yep. Thank you.
Thank you.
Yeah, I think it's just not everybody went all the way down to the geocoding of that core file in the folder. So there are some other core files higher up if people don't have that one that they could play with.
Right. So another very useful thing, maybe I can break this down into multiple lines for clarity, is while you're converting formats, you can do pretty interesting things. For example, GeoTIFF supports compression. In this case, I can use the same correlation file, and while converting it to TIFF, I can do some operations like use this type of compression and use float 16 within it. And if you run through these, it essentially does the same thing. It's format conversion with some additional options. And GDAL info will report the same information as the previous one, but it will also tell you that, oh, you've compressed it. And again, GIS systems will be able to recognize the GeoTIFF easily and work with it. Did anybody complete those steps? And volunteer to share your screen? Any volunteers? Great. So here you see all the map information remains the same. It's also a GeoTIFF. It's just a different flavor of GeoTIFF with additional compression and included. So if you do conversion from float 32 to float 16, there may be a slight loss of information, but you know coherence is a value between 0 and 1. The loss of information in that numerical range is negligible. So float 16 would be perfectly fine way of reducing disk space and representing this data. Thanks, Scott. So all these things become important as you start playing with larger and larger volumes of data. So these, one of the reasons I want to point this out, that these are problems that have already been solved. You don't need to develop custom solutions for it. Another thing we often encounter is a lot of our research groups in our universities have codes which can only handle flat binary files. If you are working on something and you have to create flat binary files, you do not need to jump through hoops to work with it. GDAL already supports a large number of binary formats. NV, example, NV is probably the most generic. If you cannot modify your workflow to use this, then you should really reconsider designing your workflow. So I would say don't create your own format for flat binary files. Use one of the standard ones already available. So that was about file conversion and formatting. Another common operation is cropping. So users may want to crop data in various different ways. One way is if you have a geocoded data set and you want to crop with the known extents on a map, you can use the sprog-win window. So this is xmin, ymax, xmax, ymin. All of this is documented on their webpage and in the link that I've provided above. So if you do the cropping, you can just directly use map coordinates. And another useful feature here is, you see, I'm outputting to a format called VRT. From the first notebook, if you remember, this is a virtual format. What this means is this file, the data is not copied out of the first image. It just points to a subset of the first image. So you're not, if you're trying to create a subset that's 500 megabytes of another gigabyte, you don't create a 500 megabyte file. This just contains the information that lets it look up the required 500 megabytes on from the original image. So I know when starting off, we do the really simple way of creating files at every step. In today's world, you will quickly run out of disk space when you're working with the imagery size of Sentinel-1. So if there is an operation that you can perform where you don't replicate the data, but point to the source data, you'll not only be more efficient in terms of time because you're doing a lot less I/O, you'll also be more efficient in managing disk space. So in this case, what I'm showing is I'm cropping to a VRT, then I pull the original source and the cropped source, and I display this. Any volunteers for this section? Anybody who managed to run that successfully?
I think you shared the wrong screen instead of the browser.
Nice. So yes, in this case, if you can see on the left, that was the original complete image. And we specified the crop box. And when you pull up the crop, it only displays the cropped region. And you see the coordinates in the X and Y axis telling you what part of the crop region you're looking at. So this is, you don't need to know what the size of the file was, what the spacing of the original file was. You're interested in the geographic region, and you do cropping purely by geographic region. That's one use case. Thanks, Veronica. The next case is also a very common use case, especially if you're working in areas like Greenland and Antarctica, or often you want to work with Landsat imagery and overlay it on your SAR imagery, and Landsat is in UTM and our ICE products are in Latlon. So in this case, we know our geocoded product was in Latlon space, and we specified the crop region in the Latlon space. In this next example, we have a data set that's in polar stereographic coordinates because it's a map of Greenland. But I know the area I want to look at in terms of Latlon space. So what you add is you specify the window in Latlon space and let GDAL translate know that you're using the Latlon for representing the window. So this would be cropping it using the Latlon region that you specified. So in this case, this is the whole Greenland map, and I specified a region that's around this area. You see these two where my cursor are. And if I plot the cropped region, it pulls out that region, and the map is in polar stereo, but I asked it to crop in Latlon. Again, you don't need to know the spacing. You don't need to know what the source projection system is. You want to share your screen? Fabiola said something. Okay, so it looks like this works. The third thing you can do is what we have been traditionally doing, where you know in the image you don't from this line to this line, from this pixel to this pixel, you were very specific about what region to crop. You can do that by specifying the source win. To do the map cropping, you use the projection window. And here you use the source window to indicate this. So go ahead, run the cell. And in this case, this is around off the coast of LA, and this is the Catalina Islands. So I asked for crop from a 500 by 500 subset with the top left there. And if you run it, it should show you the cropped part of the somewhere around the Catalina Island. And one useful thing, it automatically adjusted the map coordinates for you. In the cropped image, you don't have to write special code to read the spacing, read the top left, do the shifts yourself. Any questions so far on the two most common operations, format conversion and cropping?
Seems there's still discussion about the warning that propped up and understanding. It seems to run, but understanding what the warning means, I guess.
This warning essentially means that whoever created this netcdf file did not follow all the rules of creating it correctly. But it still has all the information. So it's just warning you that it sees this does not seem to be very correctly generated, but I'm going to try interpret it anyway, and it interprets it right in this case. So they forgot one field, which is supposed to say CF conventions at the top. All right, so another more very common operation we do is like, oh, one data set is in 100-meter posting, another data set is in 20-meter posting. I need to go interpolate it, resample it. I have to adjust the corners and the map so that things line up. If you are not changing map projection systems, if you're just oversampling or undersampling, GDAL Translate will let you do that. In this case, I think the original Greenland DEM may have been a 10-kilometer spacing product, but here we can oversample it to a 2-kilometer product. And the flag for that is this TR flag. It says, okay, I want a resolution of 2 kilometers in the X direction, 2 kilometers in the Y direction. And in this case, you can only do this by interpolating the data. You get to choose the interpolation method using the -R option. There are numerous options listed in the documentation. You can go look at that. So if you run this, it will generate it. And let's plot it. So in this case, I did not provide any cropping options. So you could have done 2 kilometers of a cropped region only, which is essentially tying together all different steps we typically need to crop a data set. And that would have cropped it. These are cropped and oversampled in the same go. So you see the original input, the oversampled input. The map coordinates are retained, so that's why the X and Y axis look the same. So simple oversampling possible. If you absolutely want to do oversampling, for example, you're creating thumbnails for your web services, you want your thumbnails to be 256 by 256, you don't care about aspect ratios, you can force the output size. In this case, I can force the output size to be 60 and 160 by 110. So it's not just for data processing, it can also be used for quick thumbnails generation and other useful cataloging. So here's the original image, and this is the quick thumbnail generated for it in TIFF formats. That's another way of regridding or resampling. Another very common operation is, 10% resampling is sufficient. So here we gave absolute pixels and line sizes in the out size. You can specify percentages, that way it will preserve aspect ratio. If you do a 10% run, again, this is 10% of the original image, the map information is all preserved, and you have a downlooked image. Any questions on regridding or oversampling? GDAL, this is very useful for DEMs in our context at least.
There was a question about interpolation methods, like which ones are good and which ones are bad, and what are the strengths and weaknesses.
There are entire web pages based on this. You should probably read up on image interpolation in general. There's no perfect solution for every case. Different imagery have different benefits from different types of interpolators. At least from the context of DEMs, most people tend to use cubic interpolation with this. The most commonly used one is bilinear. It's simple, but for DEMs and for preserving features, people tend to use cubic interpolation. Question?
Yeah, I think it also depends a little bit on what is your data set and what's your goal. So for different kinds of data sets, like interpolation of interferometric phase, there are different guidelines, I would say, than for interpolating sort of amplitude images with various noise levels and so on.
Correct. And if you're doing interpolation of a mask, say 0, 1, a 0.5 value will not make sense if you're doing bilinear, or so you would typically resort to a nearest neighbor for interpolating masks. So yeah, it really boils down to what you're trying to achieve. If you're doing interferometry, nearest neighbor DEM is fine, but if you're trying to do anything with terrain slopes and RTC, DEM, nearest neighbor is probably a terrible example. So again, it depends on what you're trying to achieve in your workflow. It's what you want, what interpolator to use. Another very common operation we talked about looks or the spatial averaging, and we've had like multiple flavors of standalone codes. At least I've resorted to just using GDAL for everything. You don't typically need to maintain separate versions anymore. Also, GDAL respects no data values and all of that. And you can achieve that by just changing the interpolation method to averaging. That's an option. And you can control the spacing. I showed above. So you can just combine those two options and have a out-of-the-box multi-looking kernel. So here's my simple function to take any input file, create an output file in whatever format you want. It can be GRD, GeoTIFF, doesn't matter. GDAL will do all the translations for you, number of looks. If you want to use a no data and say, oh, only average the valid pixels in a given thing, you get to do that. And let's run it on a couple of real data sets. So again, I'll have to rely on one of you to run these two. So if anybody who's run this, in this case, we are averaging the coherence layer. And in the second case, we apply it to complex valued data. And just to show that you don't, if you probably look at historic codes from your research group, it's like, if real value do something, if complex value do something, I think all of that becomes really hard to maintain really soon. So say a common interface significantly simplifies your life. Anybody, any volunteers for this? All right. So in this plot, you're seeing the original coherence layer, and to the right, you're seeing the spatially averaged layer, and the number of looks we applied is 3 by 3 in this case. And in this case, since the data is not, yeah, it's not a map, it's a radar geometry product. Next, if you scroll down a little bit, and on the left is the interferogram you generated yesterday or day before yesterday with StripMap app, and we further multi-looked it by 3 and 3 by 3 on the right. And we did not have to say anything to the function. We used exactly the same function to multi-look the imagery.